Last Monday of the semester, most likely, yeah? Okay. Okay, so some announcements to start. I'm going to go quick today because we've got two guest speakers. We've got Dr. Amy Childress from Civil and Environmental Engineering and Dr. Emil Geiger from Mechanical Engineering. So, yes. All right, so announcements. Your last quiz. You guys have an ethics quiz due Wednesday by 11:59 p.m., I believe. Okay. Course evaluations, they are up and running on Web Campus. We appreciate your feedback. Please fill those out. It makes the class better and better every year, so please get to that. Your final design report was due in the EDL at 4 o'clock. If you have it with you and you forgot, run quickly to Dr. Lacombe and hand it to him, please. Extra credit. The end of the semester is winding down. I hope you guys have looked at your grades. You might want to check out the column on the left of Web Campus. There's a link called Food for Thought. We put up lots of videos that we think are really interesting, and there's short quizzes after. You can do as many or as little as you like, but we think you'll enjoy them, and you get extra points. So please take advantage of that. Honors section, you guys have your extra assignment. It's due next week, December 17th. Question in the back. When's the last day you can do the extra credit? How about next Monday? Final exam day. Last day for that. Okay, so honors section, be aware your guys' project is due quickly. Final competition. Okay, just like checkpoint 5, only there's penalties. You guys can't hit the back wall anymore, and you can't go off the edge. And that is going to start on Wednesday, dead day, at 10 a.m. So you guys have between 10 a.m. and 5 p.m. on Wednesday, Thursday, Friday, and Monday. You guys saw how busy the boards were last Friday night, late Friday night, so please start early. No one has classes Wednesday, so that might be a good time to get in there. Grades, your final exam issues. We had some questions that need fixing. We're working on that, okay? So it's still being resolved. So if you've checked out that grade and it's not changing, don't get frustrated yet. We are working on it. Final clicker grades will go up probably tomorrow. CAPME will go up on Wednesday. You guys have a last CAPME due Wednesday night. So, and your grade predictions are up. So please check those out. If you're missing any grades, contact your TA or Dr. Lacombe. Okay, so final competition. You guys know what to do now. You guys had checkpoint 5 last week. We've got to get to the end of the board, turn around, and come back. If you hit the backboard, there is a penalty. Okay? If you go off the edge, there is a penalty. Fastest 5 teams get 25 bonus points. So that could make up maybe for checkpoint 5, if you struggled on that last week. The next fastest 5 get 10 bonus points. So there's some incentive. Okay? Make sure you can complete the course before you race. Right? Hitting the back wall is minus 10 points, I believe. The final competition is worth 70 points. That is almost an entire letter grade. Okay? So if you haven't buckled down and started working on this, please, please, please get to the lab. There's TAs in there every day from 10 to 7. Dr. Lacombe and I both have office hours. We're happy to help you. But please make a good final effort on that. All right, so clicker question for you guys. As we enter the final competition week, is your team making an extra effort to make sure your hovercraft can complete the course? Okay, again, it's worth 70 points. So your answers are, our hovercraft works great and is ready to go. Our hovercraft needs some work, so we scheduled some time to meet up. I think we need to meet, but we've not scheduled a time. Or we're asking Santa for a Christmas miracle. Okay, ready? Hopefully. Set and go. 30 seconds. That's relying on a lot of elves this time of year. They're busy. All right, 254, 12 seconds. Okay, 5 seconds. Anyone want some last minute responses? Get them in. 258, one person. All right, let's see here. A quarter of you guys are waiting for Santa. I don't know if he can find you. There's no chimney in the EDL. Okay. Congratulations to the 17% here. And also 52%, that's great, you guys have made a plan. So keep in mind, again, we are happy to help you. Come to the EDL and get help when you need it. Santa may disappoint you, so be careful with that one. All right. So next up, we're going to have Dr. Amy Childress from Civil Engineering. Please give her your attention.
There we go. Can you hear me now? Did you miss all that? All right, the department, ABET accredited. All of the departments here are. That's something that should be very important to you, though. Continues to be one of the most research productive departments in the college and the university. What does that mean to you? Do you care about research? You should, because a lot of us incorporate undergraduates into our research, and it's your professors who are active in the research field that will be especially interesting professors in the classroom. Also, we are ranked in the top 50 graduate schools. Civil engineering is 47. Environmental engineering is just outside the top 50 at 65. And we're in the process of the $18 million lab expansion, which is not responsible for the electrical outages you've had. So don't have ill will towards the project. The focus. So if it's not the field, the department, maybe it's the focus of our department that might interest you. Living and working in structures that are earthquake safe, having access to drinking water that is free of impurities, driving on highways free of potholes, driving on streets with traffic lights that are well timed. Hopefully in your head you're going, check, I appreciate that, I appreciate that. Knowing that your wastewater is being treated before being discharged to the river that you use for recreation. And feeling confident that when you cross a bridge it won't collapse. Something maybe we might have laughed at in the past, but you probably know of a few cases in the news where bridges do collapse. And that's our infrastructure. So if it's not this that interests you, maybe it's the job security that comes with being civil and environmental engineering. If we look, and if any of you came to freshman orientation, you saw these grades before. Grades for our infrastructure, bridges, what did we get? Every year, ASCE, the American Society of Civil Engineers, goes through and gives grades to our infrastructure. A C for bridges. I'll click through these kind of quickly. For dams, a D. For us, that's significant. We live in a flood zone, right? We're downstream from Boca, Stampede, and Prosser. So we rely on those dams. Drinking water, D-. Energy, D+. Levees, D-. Again, something we know more about in New Orleans, but also that we experience out in eastern Nevada, out in Fallon. Or that's not eastern Nevada, but out in Fallon. Roads, D-. Solid waste, C+. Transit, D. Wastewater, D-. Overall, a D in our infrastructure. So a 5-year investment is needed, estimated at $2.2 trillion. And if you are interested, I'm just going to play a moment of this, but you can go to ASCE's website. They have some great videos. I'm going to probably cut it off at...
The report card is out, and the grades are embarrassing.
If my child came home with those grades, I would not be happy.
It's a disgrace, frankly, the condition that our infrastructure is in.
But does it have to be this way?
If we want to raise the grades, it'll take a lot of money, a lot of time and commitment.
Some communities are making that commitment. Orange County, California is turning wastewater into drinking water.
Why don't you have some yourself?
Denver has rolled out a rider-friendly mass transit network.
The train's wonderful. It's packed every day.
Atlanta is replacing ancient water and sewage pipes.
People laugh about me being the sewer mayor, but they remember what I'm doing.
And the town of Napa, California is taming its wild river in eco-friendly ways.
This project will create 100-year flood protection for the city.
So there's little doubt all of America can improve the next report card.
We have the technology. What we need to do is decide that it is a priority and get on with doing it.
Good. Okay, so our mission is to prepare you for the design, construction, and operation of the nation's civil and environmental infrastructure systems. We have 2 undergraduate degrees in the department. One's a Bachelor of Science in Civil Engineering. You can, within that, you can specialize in environmental engineering. And the other is a BS in Environmental Engineering. Right now we have 375 undergraduates, 50 in the CE major, 50 undergraduates in the environmental engineering degree, and about 80 graduate students. Our students, about 35 to 45, graduate per year, go to professional jobs, graduate school, or professional schools. So professional jobs, Army Corps of Engineer, consulting firms like CH2M Hill, construction firms like Hewitt. Graduate school, University of Colorado Boulder is a recent favorite of ours. University of Illinois, Berkeley, or they stay here at UNR if we can talk them into working with us. And in terms of professional schools, we've had our graduates go on to med school or law school. So these are our 5 program areas. What I want to do is highlight 2 of them today. So I'm going to highlight environmental and water resources and structural or earthquake engineering. The thing I'm going to highlight with environmental engineering is a project on water and wastewater in space. So if you're on a mission to Mars, you have, or let me step back, for short missions, they can take their full supply from Earth, right, bottled water. A lot of people think on the International Space Station they use plants for the wastewater, treat it, and then they drink it. They don't. They do some recycling, but all potable water that they're going to drink is bottled water from Earth. But if you have a long-range, long-duration mission like the mission to Mars, then you have to recycle and reuse. So we've been looking at a system in our labs that would prevent us from having to take 40,000 pounds of water from Earth. Think about the cost associated with that and how much trouble NASA's in already. So to do that, though, you would need to reclaim wastewater from several sources. What sources of water will you have in space? Good, you're stumped. Nobody wants to think of the main source of water that you have in space. There you go, good. You do have hygiene water that's wastewater, humidity condensed from the air. It's always good to drink some sweat. And urine, good to drink that too. So those were the 3 things that we were looking at in our labs. Could we extract the water from those sources and keep a supply in space? So we were developing a system that needed to meet all of these criteria. And this is what the system looked like. Actually, we still have it in our labs. And it's currently being looked at by NASA. We are working on a project where the military is trying to do something similar in remote applications where you have people. Once again, you have a great supply of wastewater, right? Wherever you have people, you have wastewater. So in turn, you have a great supply of water. Not so pleasant to think about, but we'll talk about what wastewater you drink in a minute. So in terms of terrestrial wastewater reclamation, you saw in this video the groundwater replenishment system. It's 70 million gallons per day, but they're not sending it to somebody. They're taking wastewater, treating it. They're not sending it to somebody's tap to drink. Instead, they're injecting it into the ground to resupply the groundwater, and then pulling it out, treating it, and drinking it. So that's called indirect potable reuse. In Singapore, they have something that's called new water. It's gotten a lot of publicity, and it sounds like it's really new water, but it's reclaimed water that's going to industry. So that's direct, non-potable reuse. And Reno, at Tumwharf, we do direct, non-potable reuse as well, right? We treat wastewater, and then we use it to water our golf courses or green spaces. Does anywhere in the world do direct potable reuse, what we call toilet to tap? Yes, no, something. No, good answer. Almost though. 3 places do a little bit of toilet to tap, and these are the 3 places. Namibia, Africa, actually, they do a pretty high quality treatment on their wastewater and a lot of blending, but then it does get used for drinking water. So let me just ask you, this is the system that supplies your water, right? From Lake Tahoe through Reno, Sparks to the Pyramid Lake. I can't figure out why am I having so much trouble with the pointer? Is there a pointer on this? Okay. There we go. Okay, so we take in our water for drinking water here, and we discharge our wastewater just downstream of Reno Sparks. So we get pure snowmelt runoff, right? No, good. Whose waste do we get? Tahoe's, Truckee's. Good. So Truckee has waste. They discharge their waste. It does go through the groundwater and make it to the Truckee River. But by the time we intake it in Reno, we do still see signs of waste. They're very small signs. So is the water safe to drink? Very safe to drink. It's a very clean water. It's a good water. But it has still been impacted by an upstream wastewater. So should Reno residents be concerned about the presence of contaminants in their drinking water? No. But imagine if you didn't have a system where you had all this snowmelt runoff providing all this clean water. Instead, upstream, you just had a community that was treating and discharging their wastewater. Downstream, your drinking water is much more heavily impacted, right? Okay, switching gears. So that was an example of environmental engineering. Let's switch gears to structural engineering. That's probably the area our department is best known for, and specifically looking at earthquake or other types of loads. This shows our shake table facility in the structures laboratory. We are one of several NEAS network of earthquake engineering simulation sites. And our shake tables were actually featured in Popular Mechanics in April of this year. And what you can see is he's actually up on a curved bridge that's getting ready to be shaken, and they've got several white trucks on it. I'm going to show you this simulation in a moment. Actually, now I'm going to show you the simulation. This is my favorite all-time in 15 years simulation. So. Except it does have, it should have sound with it, but I won't worry about it. So what they did first was look at the load of just the bridge, and they shook just the bridge. But then they wanted to look at the effect of these trucks, the load of these trucks on it. And so you can go to our webpage, and specifically NEAS on our webpage, and there's lots of pretty cool shake videos, something like this. This was when we brought a new shake table online. They did this small office mock-up, so you can't probably see so well from there, but they tried to make an office like a home office or something, and after they shook that, it looked like this. So that was to kind of bring the concern of earthquakes and make it a little bit more tangible. Instead of a bridge out there, it's your office that's getting shaken up. That's what it looked like afterwards. So we have 2 student organizations, American Society of Civil Engineers, and we currently house Engineers Without Borders in our department. ASCE, the thing that they are most known for is the concrete canoe competition. This summer we hosted the national competition. It was pretty exciting. The race was at Sparks Marina, and this was in June of this year. We have the highest all-time national placement. Our students are very proud of that, and we are very proud of that. The other group is Engineers Without Borders. I'm going to quickly go through a few slides from one of the last Engineers Without Borders talks. You can kind of look up and learn about Engineers Without Borders, but the last project was a sanitation project in Brazil. So the project was to replace an existing toilet with a composting toilet. So it included many stages: assessment, design, construction, and implementation. So composting toilets are dry toilets and use aerobic processes. The key thing, they're low cost, easy maintenance, and use compost. And so these are just some pictures, as I said, I'd flash through of the construction process. And it involves aspects of all areas of civil engineering. You could say this is geotechnical in that it's the foundation of the structure itself, and then of course community education involvement, which is a key aspect of all of these projects, environmental, the water supply, the water quality, and mechanical engineering even. Voila, the finished product. And then the party. So if you have any questions about civil engineering, you can find me in SEM. I'd be happy to talk with you, whether you're in the major or not. So thank you.
This goes forward, and I believe that will give you a laser point.
Very faint. Okay. Can you guys hear me? So if you don't remember anything from today, remember this. Civil engineers build targets. Mechanical engineers build weapons. So my name's Professor Emil Geiger. I'm an assistant professor in mechanical engineering. And so I just want to give you a flavor of what we do as mechanical engineers and what we do in our department. Hopefully you learn as much from my presentation as you did from Amy's. So just a little bit of more fun. Your father's a mechanical engineer, dear. It may not look like it, but he is having fun. We're trying to break down these stereotypes, but unfortunately they still persist. We try to have a lot more fun in mechanical engineering. So again, a little bit more background like Amy gave, just coming and going. How many mechanical engineers in the United States? Well, there's, yeah, the pointer's too faint. So approximately a little over 3 million people in the United States. There are approximately 1.5 million engineers. Of those, it's about 250,000 mechanical engineers, or roughly the population of Reno. Civil engineers are comprise about the same amount of people. Top 20 best paying jobs for a BS degree. Number 6 is mechanical engineering, which I don't want you to notice is that 4 and 5 are chemical and electrical engineering. But the point is, engineering pays well regardless of, there's other engineering in the list as well. So it's a very good, well-paying career. Beyond that, you wake up doing what you love to do, and so that's more rewarding than a paycheck. So what is mechanical engineering? Well, it's the branch of engineering where one designs and creates machines and tools, things that move. And we'll look at some examples of that, but that's really the thing that I think separates mechanical engineering from other engineers, is that most of our products and designs have to do with moving things. And it's one of the oldest and broadest engineering disciplines. We'll look at some statistics about the age of mechanical engineering here at UNR in a few slides. So here's some examples of what mechanical engineers do. We have aircrafts, solar cells, cars, bullet trains, robots. This here is a picture of a human-powered vehicle competition that we do in mechanical engineering most years. This is just kind of a flavor. You can see there's all these things do. Solar cells don't move, but they move energy from the sun to our electrical grid. The other thing, though, that you don't think about when you look at this, when you design a car or build a car, there's more design than just, there's the engine, the transmission, the wheels, all of the stuff, the steering wheel, all of the controls that the user does. But then if you think about building a car and think about all of the engineering that goes into the assembly line, making sure the workers are safe, the robots that do the welds in an automated fashion. I had a good friend who just took a tour of the Tesla factory in the Bay Area, and he said it was unbelievable to see the level of automation that exists in the United States and in our manufacturing processes. So virtually anything that you deal with on a daily basis, a mechanical engineer has touched in one way or another. If it's as simple as your clothes, there's sewing machines, automation, just that put our clothes together. That was all mechanical engineering. And on down the line. The soda you had for lunch was carried by a conveying system designed and built by mechanical engineers. So our impact is ubiquitous on the human race and our lifestyle these days. So what skills and knowledge do you need to become a mechanical engineer? These are probably the same as many of the other engineers, but you need to know math, physics, chemistry, must like to solve problems, and like to work with your hands. That's one of the things that I think also distinguishes mechanical engineering is because you really can get to work with your hands a lot. Civil engineers, it's hard. You don't build bridges with your hands. You build them with cranes and other very heavy moving equipment. Chemical engineering, you don't really get in the reactor tanks. It's not safe. So that's one of the things I really like about mechanical engineering is it's very, you can really get your hands dirty with it. So introduce you to mechanical engineering at UNR. We have 12 full-time faculty. We kind of split into 3 areas: solid mechanics, thermal fluid sciences, and system dynamics and control. So solid mechanics deals with, kind of overlaps a little bit with civil engineering. That's another thing about mechanical engineering is it is the broadest, so we overlap a lot with some of the other disciplines. So solid mechanics does a lot with looking at new materials or the way they deform or they behave under load. We also do thermal fluid sciences, which is movement of energy, also flows. We have a class in aerodynamics looking at flows in airplanes or airfoils, but also heat transfer. A big area of mechanical engineering would be heating, ventilation, air conditioning systems, also heat transfer in industrial processes. I grew up in South Louisiana. There's a lot of chemical plants, and they hire a lot of mechanical engineers to do heat exchanger design, pump design, to just move the fluids around the plant. The last one is system dynamics control. This might be the quote-unquote coolest area, but that's kind of your robotics and looking at how they, automation and those kind of things. So I'm not going to go through all of the faculty, but there's 12 of us. We're hiring 2 more this year, and we've been trained at some of the highest universities in the United States. So brief history of mechanical engineering. The university, as you may know, was opened in 1874, and when it moved to Reno in 1885, there was a mechanical arts and mining engineering program established. So in 1901, the first 2 mechanical engineers were graduated from UNR. In 1903, there were 25 mechanical engineers and 6 civil engineers. Somewhere along the way, civil engineering kind of got an edge on us, but actually mechanical engineering is back in the lead with the highest undergraduate enrollments. So you can see that in this graph over here. It's really accelerated in the last 3 or 4 years. and we're doing our best to keep up with the increasing enrollments. Part of the reason why we're hiring more faculty. So this last fall, we had 520 undergraduates and 80, let's see, I don't remember how many graduate students we have. I don't have it on this chart. So, and Dr. Palmer was the professor and chairman of mechanical electrical engineering, and he's the namesake for the mechanical engineering building next door. So just a brief overview of our program. If you are in mechanical engineering or thinking about it, these are the classes you'll take. So there's a lot of design classes. And we're going to talk quite a bit about these two classes in a minute. That's the Capstone sequence, but we have all of those areas that we discussed. So thermal and fluid sciences, system dynamics and controls, solid mechanics. We also have several technical electives that you can use to either go deeper into one of these areas or go broader into other areas in the program. So when you graduate, this is what we want you to look like, a toolbox with all of these tools at your disposal: math, chemistry, instrumentation, general education. All these are your tools that you'll use for your design. And when you come to your senior year, there is, you'll see this light at the end of the tunnel. You'll be like, oh, I'm about to finish. And that light is not the end of the tunnel. That light is an oncoming train. It is the Capstone class, which I have been teaching. So we're going to take, in Capstone, we want you to take those tools to think outside the box, tackle real problems, like maybe you want to do a self-operating napkin or a hydrogen-powered car. But we will not let you do a self-perpetual machine that breaks the laws of physics. So here are some examples of, we'll have a whole slide. Let me do that first. So we have senior capstone design, where you learn the design process. You've already begun to learn it in this class. We go into it more deeply for mechanical engineering. You'll be in a group of normally 5 students for a whole year. You do a design in the fall, and you actually build it in the spring, the same project. So here's some examples. Well, next slide we'll look at examples, but we've actually been able to get industrial support for this class. We've had projects sponsored by GE, Ibarra, Amazon, Hamilton, Moment Skis. This year we have projects sponsored by a local sheet metal shop. There's a gentleman who has a shoulder amputation who we want a prosthesis made so he can play golf. So we have a project working on that. We have two projects working on aspects of quadcopters. So a very wide range of projects that exist in the capstone course. Here's a couple more examples. There's a bicycle centrifugal motion device here, wind energy harvesting, and let's see, I don't remember what that one was offhand, but very, very wide range of projects in the capstone, and it's really where we're really excited about the things that the students do every year. It never ceases to amaze us how creative and hardworking you guys are to get those projects done. I'm going to back up once and just talk about, we do have lots of opportunities for undergraduate research in mechanical engineering. Those areas include energy systems, robotics and mechatronics, micro and nanotechnology. That's the area that I work in. In my lab, I'm working with an undergraduate student on sorting algae cells. You think, well, that's not very mechanical engineering. But algae is actually a very rich source of oil for biofuels. And we're trying to sort those cells based on how much oil is inside the cells for biofuel applications. Also advanced materials research and thermal fluid systems. This is a blow up of more of the capstone projects. We actually have a ski press in the basement of Palmer, where you can actually, if you have an idea around skis, you can actually build your own skis for the Capstone design. You see the motorbike there. That group built a holder on a pickup bed that actually got a Kickstarter funding so they could bring that product to market. And so that is kind of a brief introduction in mechanical engineering. We have one. Can you design weapons if you wanted to? Maybe you can get an internship at a defense contractor.
All right, you guys, last clicker question of the semester. Now that you've heard from all the programs, which engineering is your second favorite? We know what you guys are majoring in, but which is your second favorite? So not your major. You guys have choices of biomedical, civil, chemical, computer science, electrical, environmental, material science, mechanical engineering, or I don't know. So I'm going to pull up the clicker here. Hopefully, all right. Ready, go, and I'll make this bigger, sorry. So your choice, your second favorite, what do you think you're most interested in? If we forced you to change your major today, what would it be? After that, go work on your projects. They're due Wednesday.